In these videos, I'm going to use algebra tiles to show you how to represent solving a linear equation. And whenever you are solving a linear equation, what I want you to think of is going to the store. So let's say you go to the store and you want to buy a widget. And widget is just a thing. Let's just call it a widget. And so you go up to the counter, and here's the counter, and on this side is the clerk, and on this side is you. So you say, I'd like to buy a widget. And they get a widget out from the back counter and they say, oh, here's a widget. And you say, great, thank you very much. And they're like, no, 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 no. You have to pay for it. You have to give me whatever it's worth in money. So let's say that the widget costs $3. So you get out your money and there you put $3 on your side of the counter. And the clerk says, okay, that's fair. A widget's worth $3. I give you a widget. You give me $3. We're all happy and it's good. This is a fair trade. And all that we're doing in algebra is making sure that we have a fair trade. And we can represent this fair trade using the equal sign. We say that whatever is over here, we'll just represent that with a letter, an X, is equal to whatever is on this side. So all that this equation is really saying is that a widget is worth $3. And in any algebra problem, if you're thinking about going into that store, you want to do two things. One, you want to get your widget, but second, you know that as soon as you go home, your little brother is going to ask you how much widgets cost today. And so you always have to know how much is a widget worth. Because sometimes the price changes. Sometimes this is worth $3, sometimes this is worth $4. It really depends. And when you go in, you don't necessarily know. One little side thing. The reason we use X for this is that instead of like W for widget, I mean we could use W, we could use any letter that we wanted, but we use X because algebra was originally developed by Arabic scholars whose word for something was pronounced shay'un. And when their work was translated into Spanish and Latin for Europeans, that word got spelled with an X to represent the sh sound at the beginning. And then later when they abbreviated it to just X, which is why we use X today. So going back to our store, let's look at a slightly more complicated example. Let's say I walk into the store and I'm like, okay, here's my counter. I know I want to have a fair trade, and I don't know how much widgets are worth today. So I go and I put down whatever I have in my pocket. So I'm just going to put down $5 right there. And the store clerk says, oh, okay, I'll give you your widget, but you paid too much. So I'm going to give you back $3 in change. Now you got your widget, that's great, but you need to know how much this widget is worth. And so the thing is, if the clerk is going to give you back $3 in change, like you might as well not have given them those $3 in the first place. So if I just take off these 3 and these 3, then that's the same thing. I could have just given them 2 to begin with and been done with it. And so this is how I can see that a widget is worth $2. Now, my little brother doesn't believe me about these things though. So I have to make sure that I'm recording the work that I did so I can prove it to him. So let's go back to our original equation and let's show how to put this out. So I had $5 here, so I started out with 5 on this side. And then the clerk gave me back a widget and $3. That's what we had originally. So to prove to my little brother that X is actually equal to 2, that a widget is actually worth just $2, I'm going to say, okay, well this is what the clerk was going to give me, but you know, we really didn't need those $3, so I'm just going to take $3 off this side and $3 off this side and see that now I just have one X on this side and $2 on that side. And that's why a widget is only worth $2.